All right, here we're going to look at a section from chapter 20. Now, the reason I do this section now is because it's balancing with redox reactions. And chapter 20 does deal with redox reactions and it deals with electrochemistry. So I like to put this section that deals more with just the balancing and the basic things with this back in this chapter. So this little section is actually from chapter 20. Okay. Now we're going to balance a redox reaction, and these are not quite as nice as balancing a regular equation because you have electrons that are being transferred, and when you deal with the electrons, a lot of times things change oxidation numbers, and so you're not always starting out with something being a 2 plus and ending being a 2 plus. So you're dealing with electrons being moved here, and we have to take a little more different steps to do that. All right. So here we're going to do acidic solution balancing steps. Acidics are one type, basic are the other. Basically, basics build on to the acidics. Okay, so the first thing you do for an acidic solution is you're going to split up into two half reactions. You're going to have the oxidation reaction and the reduction reaction. Then once you split the two of them, then you balance them separately. The first thing you balance is going to be any element except for H or O, because H or O are in the solution as water, so we can actually add some things dealing with the fact that water is in there with the hydrogen and the oxygen. So you pick any other element that's not hydrogen or oxygen, and you make sure that is balanced on both sides, and that's for both reactions. Then I balance oxygen using water, so I add water to either side to balance out the oxygens. I also then add H plus on either side to balance out the hydrogen. I can add H plus to a solution because it's in water and it's in an acidic solution, so I have extra H pluses around. And then we balance the charges using the electrons. Then what I do is you add the half reactions together. So I've got both of the half reactions balanced. You add them together. Okay. In order to add them together, though, you actually kind of first have to multiply the half reactions out to equalize the electrons. So this step actually should kind of be in front of that one, I guess, actually. Okay. You want to multiply the half reactions to equalize the electrons for each one. So they're both gaining or losing the same number of electrons. And then I'm going to add the half reactions together. And then you add, after you add them together, you cancel out any identical species on both sides. So it's kind of, switch 3 and 4 steps there for me. All right, so we're going to do an example because the best way to know how to do these is to do an example. Okay, it seems like a lot, okay, but if you just follow the steps are always the same. So the first thing I do is I split them up into two half reactions. So I look at this and say, okay, what things have to go together? It honestly doesn't even matter that if you know what's oxidized or reduced, okay? It might help a little bit, but you don't need to. What I do is I look at it and say, okay, I have an Mn, all right? And since I have Mn, that's obviously going to be one of my reactants, okay? And so on the right side, obviously, of that particular half reaction, I'll have MnO4 negative, all right? Then for my other reaction, I would have the NaBiO3, and obviously the Bi and the Na should go with that one. So that's how you split those up. So I'm going to first have, and I like to kind of do these in the middle with the arrows for each of them kind of being the same because you kind of add on both sides for both of them. So I like to put them kind of in the middle. And I'll do like Mn2 plus yielding MnO4 negative. And then underneath that one, I'll go the NaBiO3 into the Na plus and Bi3 plus. Okay, so those are my two basics. I like to have them kind of stacked like that so I have the things in the middle. All right, so now my next step tells me to balance all the elements except H and O. So I look at both of them and say, okay, I have one Mn on the left side, one Mn on the right side. Those are good. In the bottom one, I have one Na on the left side, one Na on the right. I have one Bi on the left, one Bi on the right, so those are all good. So I basically just have to get my H's and O's and electrons here figured out. So now what I'm going to do is I'm going to add water to balance out my oxygens. Because if you look here at this MnO4, I have 4 oxygens on one side and none on the other. So I have to add 4 waters. And I had 4 waters to balance out with those 4 oxygens on the right. Okay, I look at this bottom one and I say, okay, I've got 3 oxygens. So I've got to add 3 waters to the right because I had 3 O's on the left. Now I have 3 O's on the right. But now my H's are messed up. So this is when you go back through and say, all right, now I need to add hydrogen to get my hydrogens to match. Okay, so I have 8 H pluses, or 8 H's on the left. which means I have to add 8 H plus to the right. You're not adding H2. Okay, this is in solution. I have water. Water has lots of H3O plus or H plus and lots of water, so and OH minuses. So I add the extra 8 H pluses. Plus, it's an acidic solution, so acidics or acids have H's. All right, so there we're good there. I look on my bottom equation. I have 6 hydrogens on the right side, so I have to add 6 H pluses to the left. Okay, now I've got my oxygens, I've got my hydrogens, I've got everything else all balanced. And the only thing I don't have balanced now is I don't have my electrons balanced. So if I take a look there at that top equation, okay, we balance our charges. I have Mn2 plus, so I've got 2 positives here. On the right, I have a negative, and I have 8 positives. So I'm going to take this off for a second. So if we kind of think through here, I've got 2 positives on one side, I've got a negative and 8 positives, so I really only have 7 positives. So I need to balance those out. I can't have 2 on the left and 7 on the right. It doesn't work that way. So I got to get them equal. So that means I have to add, this top one, I have to add 5 electrons to that top one to get that to balance, to both be 2 plus. Look at the bottom one. And we should be adding electrons to the left side on this one, because they should be adding to opposite sides. All right. I have 6 positives here. I have 4 positives over there. So, yep, that works. I have to add 2 electrons to this one. And I didn't write that very well. So my electron numbers that I'm for each one is not the same, but each equation is balanced. So that brings us to the next step where it says you have to equalize the electron number. So I have to equalize the electrons, which means that if I'm losing, or if I'm kind of gaining 5 here on the top one, and I'm using 2 on the bottom one, I kind of have to find my common denominator so that my electron number is the same, so my electrons will cancel. So what you do is you have to actually multiply this top equation by 2 and multiply your bottom equation by 5. Then my electron number will be the same. It'll both be 10. So depending on how good you are at these, whether or not you can write them all out or not first and then combine them all, or whether you can just combine them all in one step. I'm going to write them out first as we get used to this. So this top equation, I'm going to have 8 waters plus 2 of the manganese 2 plus going to 2 of the MnO4 minus plus 16 H plus 10 electrons. Now look at the bottom one, and I'm going to have 10 electrons plus 30 hydrogens plus 5 of the NaBiO3 plus 5 of the Na plus 5 of the Bi3 plus 15 waters. So now I have my 2 half reactions. When you have these 2 half reactions, now what you got to do, add them together. So I take these 2 and I add them together. So I take everything on the left side and everything on the right side, and you combine them all. Okay? If you can combine and cancel in this one step, go for it. If you can't, then you don't have to. I'm going to do the next one. I'm going to write them all out again, just because it's the first one. So on the left side, I'm going to have 8 H2Os, 2 Mn2 pluses, 10 electrons, 30 hydrogens, 5 NaBiO3s. And I go to the right side, 2 MnO4, 16 hydrogens, 10 electrons, 5 Na plus, 5 Bi3 plus, and I always run out of room, and 15 waters. Now I gotta go through and I gotta cancel everything that is on both sides. Okay, so I'm gonna cancel. My 10 electrons cancel. I have 10 to start. I end with 10. I didn't go anywhere. They cancel. Kind of like spectator ions. Okay, I have 8 waters on the left. I have 15 here, which means I'm left with 7 waters that I produced. I have 16 H pluses. I have 30 here, which means I have 14. So that was going to be my final one. I have to write all this out again. Is the balanced reaction. It looks very similar to what I started out with, just with basically the waters and the H pluses in there to get them to all equal out. So now we're going to try balancing in a basic solution. Okay, so this is the same exact rules with the acidic solution. You balance it as if I had extra H plus. Then when you get done all of that last step that I just did a second ago, you add OH minus to both sides to equal out the H plus, because H plus and OH minus are just going to give you water. And you just cancel the number of water. So you kind of assume you're going to have extra H plus, or just act like you do, but you really don't. And when you get done, then add that same number of OH minus to it, but to both sides, and you'll end up with extra OH minus. I want you to go ahead and I want you to try balancing this one as you would have before, and then stop. So you're going to have an extra H plus on one side. And then I'll go through and we'll do the OH minus part together. Alright, so what you end up with there is that purple equation. Okay, it should be the final one that you would have had extra H plus. So now, the only reason we're changing it is because it says up here at the top that we are in basic solution. Which means I don't have extra H plus, I have extra OH minus. So what you do is you add to both sides the amount of OH minus that would make that H plus neutral. So I add 2 OH minuses to each side. Now what happens is it neutralizes that H plus, and you end up with 2 waters. Well, I had 2 waters on the left now. That should cancel with these 4. So I'm end up with just 2 waters on the right. My final reaction. If it's basic, we should have extra OH minus. If it's acidic, you should have extra H plus.